Section 1.2 covers types of data. The objectives in this section are to understand the structure of a typical data set, to distinguish between qualitative and quantitative variables, to distinguish between ordinal and nominal variables, and also to distinguish between discrete and continuous variables. The first objective is understanding the structure of a typical data set. For a typical data set, the numerical values that we collect from individuals are the data values. The category of what those numbers represent, for example, age, weight, blood pressure, those would be the variables that we're talking about. So if I had a classroom full of students that I wanted to find the average age and the average weight for, then the variables would be things like age and weight. The data values would be the numbers for each individual that I get. The individuals would be the subjects of my study, and all of this together incorporated forms our data set. So the values of the variables that we obtain are the data. The characteristics of the individuals about which we collect information are called variables. Information is collected on individuals, and the information collected is called a data set. We're just learning some new definitions and terminology that we will be using throughout the course. Objective 2 is to distinguish between qualitative and quantitative variables. All variables can be classified as either qualitative or quantitative. For qualitative variables, you see the root word here, quality. Qualities are typically non-numeric in value. Things like favorite color, hair color, eye color, brand of car, brand of soft drink, things like that would be considered qualitative variables. Quantitative variables have the root word quantity. A quantity is a numerical amount. So all variables can be divided or classified either as qualitative or quantitative. Qualitative variables classify individuals into categories, and quantitative variables tell how much or how many of something there is. For example, which of the following variables are qualitative and which are quantitative? A person's age. Well, a person's age is a number, so that would be quantitative. A person's gender. Gender's either male or female, it's not a number, so that would be qualitative. The mileage of a car. Gas mileage is measured using numerical values with units of miles per gallon, so this would be quantitative. The color of a car is non-numeric, so that would be qualitative. Objective 3 is to distinguish between ordinal and nominal variables. Qualitative variables can be further classified as either ordinal or nominal. Ordinal variables have some sort of a natural ordering scheme associated with them. Nominal variables do not. They're just typically names of categories. For example, which of the following variables are ordinal and which are nominal? A state of residence. States don't have a natural ordering scheme, so these would be considered nominal. Gender. Gender doesn't have a natural ordering scheme. We don't say male is better than female or female is better than male, so this would also be nominal. Letter grade in a class, A, B, C, D, or F. Letter grades do have a natural order associated with them. If they didn't, it wouldn't make a difference to you if you got an A, B, or C because they're all passing. These would be ordinal. Size of a soft drink ordered at a fast food restaurant. Small, medium, large, extra large. Those are all sizes of soft drinks, and so they have a natural order associated with them. Objective 4 is to distinguish between discrete and continuous variables. This objective is something that will be tested on almost every exam that we have in this course. The concept of discrete and continuous is not very difficult once you get it down, but until you get it down, it can be confusing. So we do test over this quite a bit because it's important to be able to distinguish whether or not your quantitative variables are going to be discrete or continuous, because that will indicate what we're able to do with that data. As we get further into the course, we're going to learn how to find probabilities and run analyses on lists of data, and what we're able to do with the data depends on whether or not that data is considered discrete or continuous. Discrete variables are what you have when you have possible values that can be listed or enumerated. For example, if you live on a farm and you've got animals, you may have chickens, you have to collect eggs. Eggs are discrete. You can get 1 egg or 2 eggs or 3 eggs. But if you have a cow and you milk the cow, you don't get 1 milk or 2 milks or 3 milks. Milk would be considered a continuous variable because it can take on any value in some interval. You could have a gallon of milk, you could have 1.34 gallons of milk, you could have 1.3459628 gallons of milk. It can take on any value within a continuum. So that means that milk would be a continuous variable, eggs would be discrete. Here's some examples to help us distinguish between continuous and discrete. The age of a person at his or her last birthday. On your birthday you are a certain year, exactly that year, so we would consider age to be discrete. Time, though, is usually continuous. The amount of time it takes you to drive to school, that would be a continuous variable, but the age of a person at his or her last birthday would be considered discrete. The height of a person can be any value measured to any level of precision. A person may be 5'2", but are they exactly 5'2"? If I want to measure it to the nearest 10,000ths of an inch, they might be off a little bit or within a certain value within an interval. So the height of a person is considered to be continuous. The number of siblings a person has is discrete because we can count. You either have 0 siblings or 1 sibling or 2 siblings. You don't have 1.375 siblings. The distance a person commutes to work. Distance is also continuous, just like height and time and weight. Continuous variables are things like height, time, weight, distance. Here's some more examples. The number of hairs on your head. A lot of people want to say this is continuous because there's too many to count. But that's not the criteria for something to be discrete. Just because there's so many you don't want to count them doesn't mean that they could not be theoretically enumerated. 1, 2, 3, 4, 5. Whereas the length of your hair would be continuous, not because it's growing, but because length can be measured on a continuum. It could take on any value at any level of precision. So your hair could be 4.375269 inches long. You could be more precise or less precise as you desire, but it's possible to break down the length of hair to that level of precision. The height of a building. Once again, we're talking height, which is a measure of length, and that is also continuous. But the number of stories in a building would be discrete because the stories are the floors in a building, and you can't have 1.5 stories in a building. Shoe size. Well, shoe sizes do come in half sizes, but it's possible to enumerate them. 6, 6.5, 7, 7.5, 8, 8.5, so forth and so on. There's nothing special about these shoe sizes other than that's what manufacturers have used for years and that's what we've grown accustomed to. But I could still enumerate these shoe sizes by just starting with an arbitrary number, 1, 2, 3, 4, 5, 6, so forth and so on. So shoe sizes, we would say, are discrete. However, the length of a foot that fits in any one given shoe size is continuous because it's a measure of length. And there's a whole bunch of different size feet that will fit in the same size shoe as long as they're off or different by maybe 1/4 of an inch or so. A lot of different size feet fit in the same size shoe. So hopefully this helps clarify what is discrete and what is continuous. At the end of this section, you should understand the structure of a data set and how to distinguish between qualitative and quantitative variables, ordinal and nominal variables, and discrete and continuous variables. Qualitative variables, remember, can be further broken down into ordinal or nominal variables. Quantitative variables can be further categorized as discrete or continuous variables. And this wraps up section 1.2.